Hello everyone, welcome to this meetup that will take place today about a mastery of testing from strategy to execution. So I will start presenting to you and I will start by presenting myself. So my name is Luís, I'm from Portugal and my studies are master degree in electronic engineer and computers. I have 8 years of international experience. I'm ISTQB certified. I have also Management 3.0 certification. And currently in Andersen, my role is lead tester responsible for the embedded section. And I already developed some projects in automotive, energy, health, and kitchen industries. So, based on my experience and some theoretical concepts, I prepared these presentations to bring to you some topics about test documentation and some procedures that can help you in order to reach high maturity in your projects and advance the points on there. So, let's present to you our agenda for today. So, first of all, I will present a text documentation, so a set and a list of documents that are normally used in tests, in some projects of testing. So then I will present to you example of test plan, test strategy, and some topics about that two documents, or one, sometimes they are together. Also, a test report and metrics definition. On this part, we will have a look in some report way and some advanced metrics that some of them are not really used in low maturity projects, but they can be very useful in terms of high maturity projects and to predict and adapt to hard situations. Then a part about handle failed tests. So it's a common behavior that sometimes we have failed tests in our test runs and executions. And how should we manage that? How can we report them? What are the best guidelines for this? It will be shared on this presentation. Then risk management and documentation, traceability metrics, logic and importance. Then the policy of proxy and RACI, two important things in high maturity projects. And in the end, a topic about change related tests management. How can we manage that kind of tests? So starting from the beginning, test documentation. As you can see, during our testing process, we are doing some activities and we have different phases where we develop specific activities and actions. Of course, in some of that phase, we have outputs that are documents like test plan, test strategy, test specification, test script, bug report, test summary report, traceability metrics, and risk document. So each document of that is specific for some phase, of course. And it's not only a good guide to guide and have the same understanding of our test activities, but also a good document that can help and show the evidence that we run the tests, we have the process well defined, and we are following good standards of quality. So based on that, let's start by test plan and test strategy. So on this part, I want to clarify to you two parts. Test plan answers the question, what test? Test strategy, how to test. So in some projects, we can see them divided. So one document for test plan, another document for test strategy. In other projects, they can be together in the same document. So it can happen in that two different ways, but I will present to you an example about that. So I guess you can see my screen. So basically here we have example about test plan. So we have different sections divided, okay, 8 main sections, and each one of them have different subsections. So first of all, we do an introduction about our product. So let's say we have the purpose of that, the product, what product are we testing, what services, what features can be also described here, test objectives, so why we are testing, what are the objectives of our testing activities, the scope, and some kind of test schedule that can help us understand what schedule we have and what are the timelines for that. Here, inside of test plan, we can see, in this case, a test strategy. Remember, it says about how to test. So here we have the test levels, what test levels we will use to test our product. Also, in the testing types, okay, and then testing techniques. So what techniques will we use to derive our test specification? Also, entry and exit criteria for testing. Then, one of the most important parts are the workflows. Here we have 3 of them: the process workflow, the review workflow, and management workflow. So 3 main workflows. The first one is the central workflow. We have 2 parts. One part about a sprint division, where we have, let's say, some kind of draft of a sprint duration. Imagine 10 days, 2 weeks. So, and we estimate here more or less that we will be 60% of the time, or 6 days, doing activities like update test cases, create test cases, update the traceability metrics, update test case support, update any kind of things related with the test cases for new features or features updated for that sprint. So then we have the blue part, 20%, where we will run the regression tests. So we will run all the tests to make sure the changes done will not affect other models or other parts. Of course, in this case, we update the bug report and we start creating the test report. And in the last block, we basically check if the report is well filled, if the documents are saved in the correct place, and if we fill all parts of the sprint goals. Also, in this section of the workflow, we have a Scrum board description, where we have a board where the team guides the different tasks during the dailies, and we have explanation for each phase of this Scrum board. So, and this is an overview about the process workflow. In parallel with that, we have the test review workflow. It's also really important. So, in this part, we have a test review process. Basically, the sprint starts, we have the creation and implementation of the test cases, can be specification and scripts, and then we have the test cases review. Then, reviewing the test cases, we start running the regression tests, deliver the test report, and another review to do. Review the result. It means review the report. If the report covers all the fields and all parts expected, if the results make sense and the results integrity, and in the end, we have the review sprint process. What is this review sprint process? It can be formal or not formal review. What it means, it's some kind of checklist in the end of the sprint that will allow us make sure that we match all sprint goals. For example, all test cases were run, we updated the test plan if needed, we report the result to the correct stakeholder, we close the tasks in Jira. So this is a checklist that will allow us touch all of that points. Of course, regarding that, you can see here some examples of checklists. For example, for test cases, here you can see, for example, the estimation field is filled, the references field is defined with a user story link in Jira. So here we have, let's say, all points that we should cover and check before send our test cases to review. It helps to increase the quality and helps to increase the time, to decrease the time spent in reviews from tech leads or from the pair review persons. Also here for the test report, for example, we can see here about the project name if it's in the test report, if we have results of automated testing, if we have test report execution from TestRail in this case, or other test management tool, and some kind of thing like that. So then we have the defect management workflow. So in this part, we have a complete diagram to explain how should we work with our bugs, and the different stages and the explanation of each stage. For example, we have here bugs in progress. They are assigned to the developers actively investigate, and work on fixing bugs. So for each stage, we have explanation. Also, we have some support sections where we explain, for example, how to report a bug, explain it step by step, how it is done in the test management tool used for the project. Then we also have here a section that it's more, let's say, to track the bugs. It can be a support for test management tool where we have all the sprints of the project, and for each sprint we have what bugs were resolved and what bugs were created for this specific sprint. It will allow us track the bugs and track the context of the increase or decrease in terms of creation or resolution. So, and then it's overview about the workflows. We also can have a traceability matrix. Here is the simple example, as in this project, it's the case only about manual tests. But basically, we have the user stories on that side and then the link for test cases that we have. As you can see, we have a link for backend tests and for front-end tests. Then we can move to test metrics and report, where we have a description and list of all metrics that we are collecting to our project and the QA process, and the template about test report. So we can see here different sections. As I referred, all of that sections are covered and validated by the checklist of the test report. And you can see the project name, the sprint date, version, QA composition team, link to task management system. It could be Jira, for example. Test environments, if I'm doing it in Android or iOS or both of them, for example. Types of testing used in this regression, test case executed, some metrics about them, user stories tested, defects, test case report execution, some kind of graph with some data about the runs, some statistics, other defect statistics, results of automated tests, product readiness for release, number of unfixed bugs at the end of the sprint, it's important, risks, QA comments, QA lead name, and the date. So it's an example of a report. There are some variations of that, but this is one example that we can have in our projects. And of course, here in test results report, it's possible to see for all sprint, we have one report filled according the template referred before and validated with the checklist that we had previously. So it's a really complete report, and it's used in this process. Also, we have in this documentation resources where we can see the test environment and tools for this project and test team composition. So basically, we can see who are the team members, their responsibilities, and then the metrics that we will speak better in the next slides. Also, a test risk management where we have the risks identification, categorization, and the measures or preventive actions for that. Test documentation and delivery, it's some kind of summary where we have, okay, what documents we have to have a look time by time, who should have a look to them, the frequency, and where they are located. So in this case, they are all here signed by links, okay? And we have the test plan, test cases, bug report, and test result reports. So that are main documents, critical ones that needs to be updated time by time. And then we have the troubleshooting, that it's not more, not less than the errors database. So some kind of setup, some kind of hints or useful information, it's saved here to allow the people share the knowledge, avoid spending 2 times the same time to fix the same issue, and things on this way. And this is the approach about that. And this is a presentation as overview about test plan and strategy. So now we will have a look on useful and advanced metrics. So as I shown in the previous document, we have some metrics like total of test cases run, total of test passed, total of test cases failed. But here I will show to you some advanced metrics that can be used and useful for projects of testing. Advantages of that. So the metrics will help us to identify quantitative measures and use them to evaluate, monitor, and improve processes, products, or performance. So we have more and more advantage than that ones, but I will let you know about informed decision making. So metrics will help us to have more and more information about some different project topics. With that, it will allow us take decisions with more information and take better decisions. Then continuous monitoring. As we have metrics, we can create some kind of target and follow the metrics evolution. For example, imagine that I want to reduce the execution time 10%. So I can see the time, the metric of the duration of the execution, and check how much it is decreasing during the time. Quality assessment and the risk identification. Also, that two parts are helped by metrics to be identified and documented. So first metric, defect density. So I guess it's more or less common in some projects of QA. So basically, this one measures the number of defects relative by a code base. So it's calculated by number of defects divided by the 1,000 lines of code, but it can be also divided by the number of models, for example, or features to identify what features have more defects density. The high density of that indicates the poor code quality or areas needing refactoring. Imagine that we have a big density of defects in a specific area, like, for example, Bluetooth connection. So maybe it needs some refactor in some time of the product development. Then defect leakage rate. So basically indicates how much bugs were missed by the QA team. What it means? It means about bugs found in production. So it's not a really good situation, but it's also important to track and understand if it's happening and in how much quantity. So basically we got the number of defects found in the production and then divide by total of defects. And it will allow understand what percentage of bugs we have in production compared with the total bugs that we have in the project. Then we have another metric that is defect turnaround time. So it means calculate the average time from bug report to resolution. So someone reports the bug and then the developer will fix that. It will be retested and closed. So all of this time can be calculated using, for example, the test management tool tasks and understand when they are open and when they are closed and do the difference between the time, and we have this metric. So evaluate how quick the team responds to the issue, and this high value can indicate some delays in communication or some misunderstanding between the parts. Then the reopen rate. So measures the effectiveness of bug fixing and verification. So here we have the reopen bugs. It's different from the previous one because in the previous one, we are talking about bugs that we open and close. In this second one, reopen rate, we are talking about bugs that we open. They are, let's say, fixed, but not really, and then they are reopened. So high rates on that suggest the QA and dev team have misalignment or some poor fixed validation. Then we have another metric, code coverage by risk area. So it's really, really close to code coverage metric, and it's a percentage of automated tests covering high-risk models. So why it matters? Not all code is equally critical. So here it's important to focus in high-risk areas. Then we have another one, text execution efficiency. So basically, it are the test cases executed per hour per tester. So it allows understand better the speed, and it's used to identify over or under utilization. So also two metrics that can be useful in our test process. Another one, and it's also another really, really important about automation ROI. It means understand how much time and money costs migrate tests or other activities to automation. So it's really important to do because it's important to understand if we are spending more money to do the automation than we will spend without automation. So of course, automation should be profitable in terms of time and money, and this metric is really, really useful to do this analysis and help in this decision if we should automate or not the specific task or specific test cases. Then the regression failure rate, so the percentage of test failures caused by regressions. What it means, it shows the impact of the code changes in the stable features. Imagine that we have some stable features and someone fixed some issue in some random feature, and it, let's say, broke a big part of them. So we can understand here the percentage of dependency between some features, and it's also helped by the regression tests. So now we will see how to handle failed tests. As you know, time by time we have failed tests in the end of the sprint. It's important to understand how to handle that, because all fail have a justification, okay? So what can be the reasons to have test fails in the end of the sprint? So bugs in the code, it can be a reason. Test environment issues, imagine that I had a different setup to my tests, or something in the hardware was broken, or something like this, or inadequate test cases, so incorrect or incomplete test data. So here are the main reasons. Of course, there are more, but they are the most significant reasons to have tests failed in the end. But okay, the tests are failed. And now what should we do? So we should have some kind of, let's say, process for that. First of all, we need to document the tests. What tests are failing and what behavior we are seeing about that. Just this. Then we can categorize and prioritize the tests, understand the impact in the product. Of course, if this step was done previously, when we are creating the design, it's not needed to be done twice. But if not, we can have a look and understand the priority and category of the test. Then analyze the cause, why this test is failing. So let's do some kind of checks to understand the cause. We can do a hardware check and run the test again, run the test in other hardware, for example, in other test bench, do some kind of pair testing, so call a colleague and try together understand what's happening, check the hardware changes, check software versions, or consequence of some bug open. So we need to understand why it's failing. Try to find the reason. Then we can create a bug report or update the bug report already open, because sometimes we have test cases failed because of bug reports that are not fixed yet, not resolved. So, but we can update that bug reports because maybe it added some new information that will help the developers on that. And then, in the end, the retest and update the report. So, if the update report with past status, so if failed, update the report with fail and the reason. So, here, explain how to fix them, and we have two situations. Situation one, after follow this process, okay, with our analysis, with our pair test or change the hardware or anything like that, our test is passing. Okay, we found the reason, that's nice. But if not, we need to fill the report correctly with that. Here you can see a part of the report, and you can see some tests with the status failed and blocked. So to handle them, we can put here in the column observations the link to the bug that is still open and is causing the failure of this test. So in principle, when this bug is fixed, this test will pass from failed to pass status. So, and the three cases here. We can also have some blocked tests. For example, this one where we have blocked, and the reason is iOS device not available. So imagine that it's needed an iOS device and you don't have that device to run this specific test about, for example, this device compatibility. We only have Android devices. So it's another reason. And in the end, the report should have this kind of appearance where we have the justifications and we have the status, test IDs, etc., etc. Okay, now we will have a look on risk management and documentation. So we can, first of all, we need to classify our risk. They can be classified by impact between low, moderate, and high. It's based on severity of consequences. So how big will be the consequences of this risk. Then the probability, low, medium, and high, based on the probability of occurrence. It will happen a lot of times, not, it's probable that it will happen or not, kind of questions like that. So by type, some kind of technical, operational, business, external, documentation, or other, based on the nature or source. By phase or scope, so what phase it's covering this risk: requirements, design, development, testing, so depending on the project stage, and in the end, by severity. They can be critical, major, and minor. So here, important point: severity and impact. They seem the same, but are really not the same. So the severity is, let's say, in terms of action. For example, a critical severity, we need to act immediately, try to fix it as soon as possible. Impact is about the consequences. So two different things. And here we have the classification of risk. Then we have one example in table. How can we classify and document the risk? Imagine the first one, user login failure. The impact is high, probability medium, the type is technically, phase in the development phase, and the severity is major. So, and we can have some kind of table like that to classify and save our risks, and then order them by, for example, impact, severity, or a combination of two columns to have the probability, high risks in the top and low risks in the bottom. Then we have the prioritization of the risk. So basically, previously we had the classification, then example of how to set the classification, and then we have the prioritization. So how can I give to my risk a priority, high, low, and medium? So we have this table that helps in this situation, because imagine if the impact is high and probability is low, the priority is medium. If the impact is high and probability is high, priority is high. So here we have in the blank parts the priority, here the probability, here the impact. And with this combination, we can classify in one word our risks. Then we can have different places to document the risks. For example, we can do a risk register. So a detailed list of risks include impact, likelihood, actions. So the same thing that I showed to you like this. We can have a risk management plan. So the final risks are managed and documented. And we have here also the measures to fix the risks. Project management tools like Jira, Trello, Logs, and other kind of tools like this. Project status report. When we are filling that kind of reports, we can have a list of risks there and share them with the stakeholders. And then quality test documentation, risks related to the quality recorded in test plans and checklists, as I showed to you previously in the last document. Then we have measures to mitigate the risks. So, okay, first of all, we need to identify the risks, document them, prioritize them, and the next part is about mitigate the risks. Okay, after you identify them, we have here the priority. We have high, medium, medium, and then a small description, and then the mitigation measures. So what we will do if this situation really happens. So we should have here some list of measures and some list of actions to can be preventive or reactive according to the risk identified. Then traceability matrix logic, it's one of the most important documents that we have in the test processes and projects. And it's very, very useful and bring to us a lot of advantages, like a strategic alignment, clear purpose, increased engagement, effective communication, tracking and evaluation, and grading cohesion. So basically here with the traceability metrics, we can make sure and know in the real time what test cases are covered, what test cases are testing what user stories or requirements have test cases done. Here is an example of a bit more complete traceability metrics. So we have here on the left side the user stories. Then we have manual QA tests, and here the links to the test cases. Then some notes, automation QA tests, and then also some notes. And the notes are helpful to give some information between colleagues in the teams, to put some information, some kind of test setup. So are notes to help run the tests or anything like this. But with this, we can make sure that our user stories has at least one test case covering them. Of course, there are some test management tools that allow to do that automatically, and you apply some kind of filters and will help you to have these traceability metrics. But it's a complement and additional document that you can have in the project, and also help the QAs to give the notes and have a quick access and vision about the status of the project. Then we have also another traceability metrics example for requirements. So we have the requirements on the left side, the description in the middle. Here, the link to test specification. So it's a more complete one because we have here where the test cases for that are designed. The task in Jira, so we should have a task to do this work, and we can put here a link. Then the test case IDs and the comments about that. And here we have a full and complete traceability matrix for this purpose. Now, I will speak to you about policy of proxy and RACI. So are quite similar, but really different, at least in terms of goals. So here you can see a policy of proxy. It means that for each task or for each relevant role, we should have a proxy, a second option person. What it means, we have a main owner and the proxy, the main responsible and the proxy, let's say. It means, for example, approve software releases. The first person is Michael Johnson, and then the proxy is Sarah Thompson. So imagine that Michael Johnson goes to vacation or for some reason is not present. Sarah Thompson assume the functions and do the stuff by Michael Johnson. It allows the people understand what one and each other colleagues are doing in the project and their responsibilities, share the responsibility of the roles, and allows save knowledge and keep the team more consistent and close each time with the same understanding and tasks inside the project. Then we have the RACI table, so where we have, it's composed by four, let's say, roles: responsible, accountable, consulted, and informed. And here it's really useful to understand who should do what. For example, in some projects we have developers doing the unit tests. In other projects, testers are doing the unit tests. So with this kind of matrices table, we can have and make sure that we are doing, we have the documentation about who should do what. For example, test planning, the responsible is the QA lead, so the person that will perform the task. The accountable is the QA manager, the person who will ultimately answer for the task completion. Then should be consulted the product owner and developers, but people that will give inputs and useful hints about for this task. And then who should be informed. So test planning should be shared with all the teams. So entire QA team should be informed. So basically this is about RACI metrics. And then the last topic, change related tests management. So basically that kind of test happens when something changed in the project. Some feature that was reworked, some bug fixed, some update in new functionality, change something according to some standard, anything. Something changed and triggered that. So, and in this case, we have two blocks of tests. One is regression testing. This block is more responsible for run the regressions and understand the impact of that changes in the global of the project. So this change, what affected in terms of project. And then we have the other block There are different kinds of tests, but they work as a block. What it means, run specific test parts to understand if the fix, update, or change in the code or project affected directly the project. So here we have the smoke tests, performance tests, security tests, and exploratory tests. All of them can be used to cover different functionalities, different parts of the project, and try to understand the impact of the changes and act accordingly. We also have the retest when we have the bugs and the bug is fixed. We have the retest to run the specific tests of that bug. So to make sure, okay, this bug is really fixed, but now we have another part that it's about the rest of the system. We need to run the regression tests. Not enough retest the bug, but practically mandatory run the regression tests. And this is the approach that should be used, let's say, to work with change-related tests. So, in conclusion, today we saw different things, different advanced topics, different points that can be used in a lot of projects and QA activities. They help us to be compliant with standards as the process defines. So we define standards and follow, for example, ASPICE, ISO 26262, and others. And when we define them in our documentation and apply them, when we follow some advanced points shared here, allow us to make sure, for example, add this point to checklists to review, add them to test plan will help absolutely to make sure or really close that we are matching them. Reduce the ramp-up times when we have the information clear, the test plan documented, and the how-tos documented together in the test plan. The new team members will have a really, really short time to ramp up and start producing in the project. Save money and time in terms of not only loss of information. Imagine someone lose the company and you don't have the information saved anywhere. So it helps us to make sure that this information is saved, and also saves money and time when we do the things following the right standards. Save the project knowledge, as explained it before, and keep the same understanding about activities and responsibilities. So with this RACI and proxy that I shared previously, it's a common understand who person should do what, and it's clear for everyone. And of course, prevent unexpected situations with risk analysis, risk documentation, metrics to identify the risks. So all of that topics together can increase absolutely the maturity of the project and increase the quality of the work. That are the main conclusions of our presentation. And now I can pass the time for questions. Okay, as we don't have any question, let me say to all of you, thank you for your participation. Thank you for being present in this meetup. We have here the QR codes to share your feedback if you like it, share your suggestions, anything. Thank you a lot for your presence. My pleasure to be here with you, and see you soon in other meetups. Wish you a great day. Thank you.